Okay, so hello everyone. In my last video, I have given the questions asked in my Texas Instrument interview. In this video, I will be giving you the solutions, and I will be discussing in very detail how you should approach. So let's get started. So the first question was this. This is the very basic question that every analog interview starts with. So this is the basic RC circuit. Where they have connected the input voltage source, and they have asked me to plot the current and voltage of the output, and then they have also told me to calculate the voltage of R. So in my interview, I just directly told them the answer. I have directly drawn the plot, but they insisted me to tell the process, what was my thought process, what I thought before this. So I told them that at t is equal to 0, the capacitor will be shorted. So they were like, what made you think this, and why at t is equal to 0 the capacitor will be shorted? So the answer was, at t is equal to 0, let me change the color. Yes, at t is equal to 0, we have abrupt change in the input, like the input is changing. Okay, so we can tell that the frequency of the input is infinite. That's why S is infinite, and we have the Xc is equal to Sc. So if this is infinite, so 1 by infinite is 0. That's why the impedance of the capacitor is 0. That's why I have made it short. They were like, okay, then go on. Yes, so as it is shorted, the V out will be 0. V out will be 0. V out will be 0, and the current will be V in by R. Okay, it will be V in by R. Yes, so V in is 1 and R is 1. So we got I is equal to 1 milliampere. Okay, so this two information we got, this and this. Okay, sorry. This two information we got, and now at t is equal to infinite, we have S is equal to 0. That's why Xc is 1 by 0, which means infinite. That means it is open circuited. So as it is open circuited, this is open circuited. Okay, this is open circuited, and the current is not having any path to flow. That's why the current will be 0, and we know that Vc is equal to 1 by C integration of I into dt, right? So if the current is 0, there will be no further charging. That's why the voltage will stop building. Okay, so when it will stop when the current is 0, and we also know that the current here is 0, right? So when the current will be 0, when the voltage difference, this is V in, this is V out, when the voltage difference of V in and V out will be same, then the current will be 0. That's why our V out will be V in and I will be 0. So from this four things, we can easily plot the waveforms. So let's plot it. Okay, so first this is T. So first we'll plot the output voltage. So first it is 0, and the typical RC behavior, it will go exponentially and then it will settle to V in. So this will be V in. Okay, and the current is 1 milliampere. We'll just change the color. The color is current is 1 milliampere, so it will start from 1 milliampere and then it will decay down. Okay, so this is the current. So they also told me to draw this. So like they told me to mention the extreme points. So this was it, and they also told me to draw plot the graph of VR. VR means this voltage across resistor. So voltage across resistor, I just directly told them the VR is equal to I into R. So it will follow the same graph as this. If I want to mention it, this will be like this, something like this. Like this is one, right? So it will be like this from V into this. Okay, so this is VR, this is V in, and this is current. So this was the answer for the first question. And proceeding to this, like after this question, they asked me what will be the pole of this system. So I directly answered them that SP will be 1 by R equivalent into C equivalent. That's why it will be 1 by RC. They were like, okay, that's fine, but what made you think this? Like, from where you got this equation? So they told me to explain how you should find a pole of a system. Then I told them, like, the pole is when V out is infinite. Okay, and in this case V out is I into XC, right? So for calculating a pole, we can have two cases. One case is I is finite, and X is infinite. Okay, and second is I is infinite when XC is finite. These are the two conditions that you must check. So let's see, when first we'll make XC as infinite. So when XC will be infinite, at S is equal to 0. So at S is equal to 0, the XC will be infinite. So can we call it as pole? No, we can't call it, because the current is not finite. If this is open circuited, like XC is infinite, that means it is open circuited, right? So if it is open circuited, then we don't have any path, I 0. That's why I is not finite, I 0. Okay, so we can't call it as pole. So what is the second condition? The second condition is I should be infinite, and we know that I is equal to V input divided by Z1 plus Z2. So we can replace this as, this is R, this is C. So R is Z and C is Z2. So this is R and this is C. So Z1 should be minus of Z2, then this is 0, and then we get current as infinite. So this should be there. So from this I got it, this. So from this I can write SP is equal to 1 by RC, like minus RC. Okay, so this was the question. So this was the first question, and they went to another question, but here you can also think of poles, like zeros, and you can also think of how to plot the body plot, the phase and margin, phase and magnitude. That two things you should also see, and if you want me to make the video on that, you can comment. Okay, so going to the next question, they replaced the voltage source as the current source, step current source, and they then told me to do the previous things. Okay, so here I is constant, Okay, so that's why VR will be always 1 volt. 1 volt. Okay, so this will be so VR also will be constant. So I have not mentioned there. So I just told VR will be constant. VR is also constant. Straight line. Okay, VR is a straight line. This is straight line. Then it is 1 volts. Okay. Here we have this, and then the VC is equal to 1 by C integration of I into dt, right? So the I is constant, so we have VC is equal to 1 into T, and C is 1, that's why we have T. So this is there. So we can plot this as it is T, that means it is passing from an origin with a slope of 1. They also asked me the slope, so the slope is 1. Okay, so this is the V out, and the current is constant. Current is constant, 1 ampere, and same of this is also VR is also constant, 1 volt. Okay, so this was the second question. Going to the third question. Now they have added a capacitor in parallel with a resistance. Okay, so they have added a capacitor in parallel with a resistance, and now they have told me to calculate the answer. So here at t is equal to 0, you can see you have a path like this. At t is equal to 0, both capacitor will be shorted. So this in this path the resistance is more, and in this path the resistance is less. That's why the current will follow this path, and the voltages will start to develop. And one more thing that you can see, this is 1 ampere. This is 1 ampere, and now it is dividing into 2 parts. At the first, this is 0. Whole current is passing from this, and now it is getting into here. So you can say in this branch there will be always 1 ampere of current. So we can directly tell V out is equal to C into I into dt, and that's why it is T. Okay, so V out was this, but they also told me to calculate this IC1 and IR. How will be the waveform of this two? Okay, so at start IR is 0, and what do you think what will happen at t is equal to infinite? So at t is equal to infinite, so at t is equal to infinite, this will be open circuit. This will be open circuited and will be having some voltage, but the current will be 0 from this branch. So the whole current will be passing from the resistor. That's why we have at t is equal to infinite, at t is equal to infinite, R is equal to 1 ampere. Okay, and we can also tell that VR is equal to 1 volt, and here VR was VC1. Okay, so now we'll plot it one by one with this analysis. Okay, so first plot V0. V0 is a straight line. No, there will be no issue in that. Okay, but VC1, first VC1 is 1 ampere, and then it starts to decay. It starts to decay to 0 ampere. So that's why there will be like this. So from 1 ampere to 0 ampere. And IR will be from 0 ampere to 1 ampere. Okay, so this was the question. Yes, and now in this question they have removed the capacitor from the top. this capacitor was removed and they have connected it here, and now they told me to calculate the do the same analysis as previous. So let's make it up. This is also 1K. Yes. So at start, at t is equal to 0, at t is equal to 0, both capacitor will be shorted. So this is also shorted and this is also shorted, but we have two branches in parallel. This branch is shorted, but this branch is connected with resistor and then shorted. So this branch is having a resistor and this branch is directly shorted. So the whole current will be traveling to this node, to this branch. Okay, so whole current will be traveling, and this has a zero current at the start. That's why V out is 0. Okay, V out is 0, and now this let's call it as VC1. Okay, so now VC1 is getting charged with so IC1 will be 1 ampere. Okay, and let's call it as I0, and I0 is 0. And at t is equal to infinite, okay, so now check what will happen at t is equal to infinite. But before moving to t is equal to infinite, I would like to share some concept here. See, this voltage is getting charged due to the current. So this voltage will be increasing, and this is at 0. So if this voltage is getting increased, there will be some voltage across this resistance. Okay, so if there is some voltage across this resistance, so there will be a current in this direction, and due to that current, this current will charge this capacitor. So in this interview, I haven't explained this thing at the start. They told me like I have just gave the t is equal to 0 and t is equal to infinite, and then they have told me from where you got this result, what is the process. So I'm just explaining you this. So as this voltage is getting increased and this voltage is smaller than this, so there will be current here, and this will charge this voltage, and at the point this is also getting increased, this voltage is also getting increased due to this current. So and here in this branch the current is being decreased because this current is increasing, right? And we have a same current passing through this, so 1 ampere. So at the previous this was 1 ampere, then let's suppose this is drawing 0.1 current. So what will happen to this current? This will shift it to 0.9, right? And then again after some time this voltage will also be increased, so the current will also get increased, so it will get 0.2 and then it will get 0.8. So that's how the current will be getting increase in this branch due to increasing the voltage of this. Okay, and at last what will happen when you can see at t is equal to infinite, like s is equal to 0, so both the capacitor Xc is much higher than R. So what type of circuit you get? You get R, like you get let's replace that X. This is, suppose this is Xc, this is R, and this is Xc, and Xc is much higher than R. So what will happen? So we can say this two branches, this branch and this branch is having one and the same current. Like same resistance. So if they have same resistance, then the current will be same. So now they ask me what will happen at t is equal to infinite. Will the current will be exactly same? So I said at the high frequencies it will not be exactly same. There will be some difference, but at t is equal to infinite, where the frequency is very much small, at that time there will be a same current. Okay, so this was the case. There will be a same current. Yes, so IC1 and I0 will be same, and both the capacitors, as the capacitor values are same, so dC1 by dt is equal to dC0 by dt. This is C0 and this is C1. Okay, so this, both the capacitors are getting increased with the same rate. Okay, at the first, this capacitor was getting increased and this was stopped, but due to this current, the rate of change of voltage of this capacitor was getting increased and this was getting decreased. So at the end, both the capacitor will be having a same rate of change and the same slope. Okay, so let's draw the graph then. With this information, let's draw the graph, plot the graph. Okay, so yes, so at the start, what was the slope of VC1? VC1 slope of VC1 at t is equal to 0 was 1 by C into I, that was 1. So it was increasing in this fashion. Let's assume this has a slope, and the voltage of this branch was 0. At the start it was 0, and then what happened? Due to the current in this branch IR, this started increasing slowly. Okay, then it gets increased slowly. So this was increased, and then at last this was getting increased this way, and at last it was settled to the slope of, okay, so at last the slope of VC1 and VC0 was same, that was C into 0.I, that was 0.5. Okay, so at last both the slope was same. Okay, so this was the graph. So this is VC1 and this is VC0. So now they have asked me, so this slope is 0.5 and this slope is 0.5. Okay, so now what is the difference of this two? So the difference of this two will be the VR. So what is VR? IR into R. So I is, so as the resistance and capacitance is in series, so IR will be IR will be 0.5 and VR will be 0.5 into R. This is 0.5 voltage. So this will be 0.5 volts. Okay, so this was it. So now let's go to the next question. Is anything remaining there here? Yes, we have covered this. VSN, this the same, and yes, I0 will be constant afterward. Yes, let's also draw the plot of I0. So I0 will be like this. I0 will be increasing, and then it will be settled down to 0.5 ampere. Okay, so let's go to the next question. So let's I will explain the op-amp question in the next video, and I will just quickly cover. Okay, so I think this video is getting so long, so in the next video I will cover the rest of the questions.